In 1998, there was only a single piece of the International Space Station in orbit. The Russian module, Zarya, floated entirely alone, racing around the Earth at roughly 17,000 miles per hour. The completed station weighs over 900,000 pounds. There is no rocket in existence capable of launching a structure of that mass and volume all at once. Building it required a modular approach, using the Space Shuttle as the primary delivery vehicle to haul individual sections into orbit over dozens of separate missions. The engineering challenge was significant. Astronauts had to take enormous metal cylinders, designed and built by different nations, and force them to lock together in zero gravity. Survival in orbit depends on the integrity of these seals. A single failed connection or a leaky gasket would result in the loss of a multi-billion-dollar station. During STS-88, the shuttle brought the U.S. Unity module to join the Russian Zarya. However, their docking ports were physically incompatible. To bridge this gap, engineers used the Pressurized Mating Adapter, or PMA, acting as a mechanical translator to join the different hardware. During the mission, the shuttle's robotic arm lifted the Unity module out of the payload bay and secured it. To complete the connection, the shuttle fired its thrusters, physically pushing the modules together until the latches on the PMA engaged. This maneuver successfully joined the very first two pieces of the station. This connection proved that it was possible to integrate hardware from different aerospace programs in orbit, setting the stage for every module that followed. In 2001, mission STS-98 delivered the Destiny module. This massive cylinder would serve as the station's primary scientific laboratory and the center for its U.S.-based research. Installing it required a logistical reconfiguration. The port on the Unity module where Destiny needed to go was already occupied by a PMA adapter. Astronauts had to detach that adapter and carefully move it to a temporary location to clear the way. The shuttle's robotic arm then hoisted Destiny and rotated it 180 degrees. Because the module was so large, the arm had to move with extreme precision to avoid colliding with the station's existing structure. Once locked into place, Destiny provided the station with a dedicated workspace for scientific experiments, changing the station from a simple living quarters into a functional laboratory. Early construction relied on the shuttle's own robotic arm. However, because that arm returned to Earth with the shuttle, the station remained static between assembly missions. Mission STS-100 changed this by delivering Canadarm 2. This was a larger, more sophisticated robotic arm, designed to stay in orbit and move along the exterior of the station's hull. The handover was performed by having the shuttle's arm lift the new arm out of the cargo bay and pass it directly to a docking point on the station, a maneuver often called the Canadian handshake. By the time mission STS-104 arrived, the new Canadian Arm 2 was ready to assist. It was used to lift the heavy Quest airlock and maneuver it into its permanent position on the Unity module. Quest provided a dedicated space for astronauts to suit up and step out into the vacuum. This meant they no longer had to rely on the shuttle's airlock to perform spacewalks. With its own robotic arm and a permanent airlock, the station gained the ability to maintain and upgrade its own exterior, achieving a new level of operational independence. Today, the station has grown from that single Russian cylinder into a complex orbital structure that spans the width of a football field. While the modules are the most visible parts, the station is sustained by thousands of personnel on Earth who monitor the data and guide every robotic movement from mission control. The ISS serves as a long-term case study in modular construction. It demonstrates that humanity can successfully build and maintain separate, pressurized environments in the vacuum of space, providing a foundational set of lessons for any future outpost on the Moon or Mars.